Hi everybody, we continue review in Math 1324, question 61. On this one, we just add the two matrices together. So if we do it by hand, so that is A plus B then we just add the corresponding entries. Negative 9 plus 6, 1 plus 2, 2 and 1, 5 and 1. So have negative 3, 3 and 6. This we have a matrix A minus 2 times the matrix B. So just like all the operation, multiply, divide, and then add or subtract. So I multiply the 2, just the 2, keep the minus. So negative 2, 6, and negative 4. And then we subtract. Subtract the corresponding entry, 1 minus negative 2. Negative 3 minus 6, 2 minus negative 4. Three, negative 9, and 6. Right, now I'm just gonna show you, just do one problem on the calculator. So if you have the TI-84 like this, we just enter everything on the home screen. So hit alpha and zoom. But first there's A, so matrix A, alpha, zoom. And this one is a matrix of 3 row, 1 column. And then when you in this environment, don't hit enter until you want the answer. So just hit 1 and then hit down to the negative 3. And also this is a negative sign, not the subtract. The subtract is between two numbers. The negative is in front of a number. Right. There's a 2 here. Right. And then minus 2. Alpha zoom. And then negative 1. 3. And negative 2. Right. Just like that. So everything in the home screen. Right. Let me write the timestamp. Right. Now we have the application of this problem, but it just pretty much just multiply together. Let me do this quick. Right. So we have the final grade. We have the student 1 to 4 here, and the midterm and the final. Right. So for this we will find the final score of the student 3 for both the grade system 1 and 2. So if we want the student 3, we will use this row. And for both systems, we're going to be both column. So in that case, we just take this row times the column of 0.3 0.7, 0.5, and 0.5. So multiply row by column. 85 times 0.3 row times column. Right, now let's check the dimension first. So this is a 1 by 2. This is a 2 by 2. So the middle numbers are the same. We're going to have the 1 by 2 matrix at the end. So 85 times. Okay, we may not have enough space, so let's just write here. 85. Okay, row times column. 85 times 0.3, 90 times 0.7. So that row times column. And then 85 times 0.5, 90 times 0.5. Right. So just type, use the calculator here. 85 times 0.3 plus 90 times 0.7. 88.5. And then the other one. $87.5. Right. So just do that. So just create the information. So this is student 3, so we just want that row. And for both systems, so system 1 and system 2 correspondingly. Right. Find the product of matrix A and B if possible. So A is the 2 by 3, 2 by 2, and B is 2 by 3. The middle number are the same, and to the outside is the product 2 by 3 is the dimension of the product. So it's A, B, right. So again, it's going to be a 2 by 3. So this is the dimension of the product. Right. So this entry is on the first row, first column. So we use the first row and first column. Just do that. First row and first column. So negative 1 times 0 is 0, 3 times 1 is 3, so that is 3. Right? And then first row, second column will give us this. So negative 1 times negative 2 is 2, minus 9, minus 7. Negative 1 times 5 is negative 5. Negative 5 plus 6 is 1. And then we're done. Now we go to the second row. First column will be this one. 1 times 0, 4 times 1 is 4. So 1 times negative 2 is negative 2. Negative 12, negative 14. And 1 times 5 is 5, 4 times 2 is 8, that's 13. Yeah, you just take a row times a column. That's pretty much it. Of course, we can put in the calculator too. 2 by 2. Right. Okay, we have that. Right, the timestamp. Right, next. Shows the matrix using inverse. Of course, there are a lot of different ways to use this. Reduce row echelon form or anything similar to that. So here we use the inverse. So we will write this as the system, as the matrix equation. First, we write all the coefficients. And then we write the variable. And then the constant on the other side. Right. Now this system is a x equal to b. So will be x equal to a inverse times b. Inverse of this, inverse of 2 by 2 is 1 over negative 5 times negative 6. So this direction minus that direction. And then switching this, and then change the sign of the other. So that inverse of a now times b. Right, so that is 1 over 30 minus 9 or 1 over 21. I will multiply the matrix into that first. So that gives us negative, just use the calculator here, negative 6 times 8 minus 3, I'm sorry, have to plus negative 3 times negative 30. So that's 42. And then the row, second row times that, negative 3 times 8 plus negative 5 times negative 30. So 126. And then you multiply the 1 over 21 into that. It's going to be 2 and 5. Sorry, 2 and 6. Right. Right. Now we do this two problem of decoding and encoding. So we use this matrix to encode the message. So first, if we have the message like this, we find the corresponding and put that in the matrix. So life in numeric term is L is 12, I is 9, F 6 excuse me, and E 5. We put this in the matrix form in column 12, 9, 6, and 5. So this is the measures, but we have the encoding matrix we multiply to it. And that gives us 3 times 12, 36. Now let's just use the calculator on this one, just for practice. Right, so we have that. And so this is the encoding message. Right. Now, if we have the encoding message, that we can give that to anybody. So if you want to decode that, you're going to take the inverse of that matrix, multiply this, you get back to this. Now that's what the next one. So we have the inverse A and then the inverse. And this is the message we try to decode. So we're going to take the inverse. And multiply to the message. Um, 9 times negative 7, not negative 63. And 64, negative 63 plus 64 is 1. And then this row times this column. Negative 72, negative 72 and 84, that 8. Wait. 72, 84. So that's 12, sorry. 12. Now second row, negative 7 times 2, so negative 14 and 16, that's 2. And 2 times negative 8 is negative 16, 21 minus 16. Then 1 minus 16 is 5. Then we look, 1 is A, 2 is B, 12 is L, and 5 is E. So the message is able. And next we go to the system of equation. So graph the solution set of the system indicate. So we just going to graph the system equation. So first one, we just graph one by one. And so x plus 2y greater than equal to 2. Now first we're just going to graph the equal sign. So we have just graph the equal. Now make it equal to. For this I'm going to choose x equal to 0 and then y equal to 0. X equal to 0 and then y equal to 0. When x equal to 0, you have 0 plus 2y is 2. So y is equal to 1. So in that case we have the point x equal to 0, y equal to 1. Right. And now when y equal to 0, we have x equal to 2. Now this one is easier, 2 and 0. So there's 2 points, 0 and 1, and then 2 and 0. Now we do the test point to see if we, by the way, it has an equal sign in here, so it will be a solid line. Right. Now we pick a point to see if we set above or below it. Let's use the test point of 0, 0. So put 0 and 0 in here. And we have 0 greater than equal to 2, that is false. Now if this is false, we're not going to set the point containing this, we're going to set opposite to it. So it's going to be this. That's the first part. Now we graph the second one. Now if we just graph the equal sign, if we choose x equal to 0, then y is equal to 0, so we do have the point 0, 0. And now if x is equal to 1, then 1 minus y is equal to 0, so y is equal to 0, 1 as well. So we have the point 1 and 1. So 0, 0, 1 and 1. Usually you want to choose the point where it is a bit further apart, so it's easier to graph. But regardless, it has the equal sign here, so we do have a line. Now, if we test 0, 0, it will not work. We have to choose the point that's not on the line. So let's say, how about this point, 0 and 2. So we're going to put in here 0 minus 2, is that less than equal to? Negative 2 is less than 0, so that is true. So we say the point containing this, so that point belongs above the line, so we say it above the line, so it will be like this. And of course you see the overlapping is between the two lines. That's where we use this. So it will be that. Right. Now we'll go to 69. Right, so this of course we'll graph one by one. Now let's just graph when it is equal to. When x equal to 0, we have 2y equal to 54, so y is equal to 27. And when y equal to 0, 3x equal to 54, so x equal to 18. So we have 18, so we have that. Now test point, I would choose 0, 0, and put in there 3 times 0, plus 2 times 0 greater than equal to 54, and that's why it's true. Right, so we have 1. Okay, we don't graph it yet until we see what will be the to put on the coordinate system. That's the first one. Next, for x plus 5y less than equal to 100. Now make it equal to when x equal to 0, 5y is 100, so y is equal to 20. When y equal to 0, for x equal to 100, that's 25. I should have that. Now we still do the test point. 0, 0. Put 0 and 0 to the equation. And that 0 less than 100, that's also true. Alright. So now let's graph. We see the x that go from 0 to 25 and the y 27, 20. So we have to choose the coordinates so that will cover enough. So see, this I think have 10 on each side. So let's say 3 each. So 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. That's good. Right. Here we have 0 and 18. I'm sorry, 0 and 27 above the point. Okay, here. And 18 and 0. And by the way, we have x greater than equal to 0, y greater than equal to 0. So that's why we only have in this first quadrant here. And the point is true, 0, 0 is true. So that means the 0, 0 belongs to the region. So that below this line. Next step, 0 and 20. X equal to 0, y equal to 20. And then x equal to 25, y equal to 0. So this line. Okay, that look like yeah, we'll find the intersection later. But again, the point 0, 0 is true, so the point 0, 0 true, and that point belongs below the line, so we'll graph it below the line. And of course it is in that quadrant because x is greater than 0, y greater than 0, so in that quadrant. So with that we have this region. So we need to find all the intersection here. So this is easy. 0, 0. That is 20 and 0. I mean 0 and 20. This one. That to be determined. And that is 18 and 0. Right. Now this is the intersection of the two lines. So we've solved the system of equation. 2y equal to 54 for x plus 5y equal to 100. And the previous section we can use the reduced to echelon form. So we form this matrix. And then 54, 100. And we do reduce to echelon form. Second matrix. I have 10 and 12. So that is 10 and 12. And 18 and 0. So that we have. Right. Graph the solution set of system. So this is like the one on 68. So first mode graph negative x plus 3y less than negative 15. Now this one has no equal sign, so that would be graphed by a dash line. Right. Now we assume that is equal to, when x equal to 0, 3y equal to negative 15, so that is negative 5. And when y equal to 0, x equal to 15, well, that's not very good. We might want to do something else. We can graph. I said, if x equal to something that, let's choose y. Let's see. Y equal to 3, for example. 3y is 9. No, not that. Not even. Negative 3. That's better. Okay. If y equal to negative 3, you have negative x plus 3 times negative 3 equal to negative 15. So that negative 9 moved to the other side is 9. It's negative 6. Sorry, negative 6 and negative 3. Y equal to negative 3. Sorry, negative. Sorry. So x is equal to 6, positive 6 and 3. 6 and 3. Negative 3, okay. So just write point 6 and negative 3, right. And this point is 0 and 5. Negative 5. So those are the points. Okay. Now this is a dash line because we have no equal sign. Now test point. Now if we test 0, 0, test pawn, we just use the pawn not on the line, and we have -0 plus 3 times 0 less than -15. So that's 0 less than 15, that false. So we have to say below the line. Right, and now we graph the other one, x greater than or equal to 2. That's easy. 2 is the vertical line. It has the equal sign, so it will be the solid line. And I will just say when x equal to something like 0, 0 greater than or equal to 2 is false. So this pawn is false, meaning we have to go to the opposite. So we have this. That's easy. Now we do 71 and 72 together. So just find the maximum minimum for all these pawns. So pretty much we just put the pawn into the function, see where's the maximum, where the minimums are, and that should be simple. So we have a table. There are 5 pawns. Let's go from here. Just put x and y in it. So 18. '21. 63. 54 and 63. So like 13 times 9, 117. And then 6 times 9, plus 7 times 3, 54 and 21. Whatever it is, not going to be a maximum or minimum, but just 54, 21, 71, 1 and 4, so 75. Like I said, this need a max or min because the maximum is here and the minimum is here. So we should say maximum equal to 117 at x equal to 9, y equal to 9, and minimum equal to 18 at x equal to 3, y equal to 0. Right, to be just like that. Same thing here, we will draw a table. x equal to 3 and y 3, x 2 and 5, 4 and 2. Now this is the x plus 5y at 18, x plus 5y 27, and then no, this one just find the maximum, and then x plus 5y at 14. Of course the maximum is 27. But x equal to 2, y equal to 5. Right, so that is that. Now we have this one. Two type cargo A and B to be shipped in the truck, and the weight and the volume given by this. The shipping company charge 75 for cargo A and 100 for cargo B. Maximum load of that and that. How many of type cargo to be shipped to maximize the profit? Right. So usually when we do this type of problem, we look at the question. What do we want? How many of each type of cargo should be shipped to maximize the profit for the shipping company? So that type of A and type of B should just say A and B as the variable, right? And what time would turn anything A and B have to be greater than equal to 0, right? Now the volume, each cargo A is 50 cubic feet, cargo B is 10 cubic feet, so we have 50 times A plus 10 times B, and the cargo cubic feet, that is 100 cubic feet maximum. But we cannot exceed that. We can have less, but we cannot have more, right? And now talk about the weight. I will have 200 for cargo A and 360 for cargo B, but again they have to be less than the limit. And then the profit is $75 for cargo A and 100 for cargo B. And then we have the equation, system of equation. 50A plus 100B plus 10B less than equal to 1000. 200A plus 360B less than equal to 7200, and A and B greater than equal to 0. And because the profit is to be maximized, so that is wrong. The next one is not a work problem, but we have the equation ready. We just want to add and solve for it. As said before, timestamp. Right. An objective function and the system of linear inequalities represent. Okay, so we have this. So we try to use this value to determine the maximum value, so we try to find the maximum of this subject to this constraint. Once again, we have x and y greater than or equal to 0, so that will be in this quadrant here. So what we're trying to do is we find the feasible region and then find the corner points, evaluate the function at the corner point to find the maximum or the minimum. So let's just look at each equation or inequality, this one. Right, now let's just look at the case when it is equal to. Make a table. If possible, we choose 1 to be 0. If x equal to 0, we don't have x. 3y equal to 12, so that is 4. Now if y is equal to 0, we don't have y. 2x is equal to 12, so x is equal to 6. So we have 0 and 4, 0 and 6. Now the test point. And we choose 0, 0. Put that in here. And they have 0 less than 12, so that falls. And this is the solid line. The reason this point have already the point on it, so we just go ahead and have to draw it. If we have the blank axis, then we have to choose. We have to choose the corner, so that look reasonable. And this is false. Sorry, to 0 less than 12, so that is true. Sorry. Yeah, 0 less than 12, yes. So it's below the line. By the way, we do know that it have to be above this line and on the right this line. That's the first one. Now the second one, 2x plus y less than or equal to 8. Now when x equal to 0, y equal to 8, and when y equal to 0, x equal to 4. And then test point. We certainly can use 0, 0. Again, 0 less than 8. That is true. X equal to 0, y equal to 8. X equal to 4, y equal to 0. In this section here, look like 3 and 2, but we cannot guarantee that, so we just have to solve for that. So in this section, again, system of equation. Elimination, substitution, matrix, whatever method you want to, you can just use whatever you want. Just going to use the calculator here. Right. Second matrix, math. Three and 2, yes, indeed it is 3 and 2. Of course, the overlapping will be this. Right, let's try the point 0, 0, 0 and 4, 4 and 0, and 3 and 2. So we have those points. Put all of that on the table. Of course, put 0 and 0, that gives you 0. Sorry. Suddenly I switched the pen. Hmm. 7 times 4, sorry. Either way, 24. 6 times 3, and then 7 times 2. So that 18 and 14, 38 and 4, so that 32. 6 times 4 plus 7 times 0, so that's 24. Of course, the maximum is 32. So maximum equal to 32 when x equal to 3, y equal to 2. Right, so that was that. Timestamp. The Southern States Ring Company decided to sell two types of rings, brass and aluminum. Can produce 24 each day and up to 60 man-hours. Take 3 man-hours to make one brass ring and 2 hours to make one aluminum ring. How many of each time should be made daily to maximize the company profit? If the profit is 40 and the aluminum is 35, so we have brass is 40 and the aluminum is 35. So that is the profit. $40 for each brass and 35 for each aluminum. This, of course, we try to maximize and it can produce up to 24 rings. So meaning that B plus A have to be less than or equal to 24. So it cannot be more, it can be less, it can be equal. And 60 total man hours. So it takes 3 hours to make a brass ring and 2 hours to make an aluminum ring, and that have to be less than or equal to 60 man hours. And of course we have A and B greater than or equal to 0 because quantity cannot be negative. Right, so we have this system equation subject to that, so just go ahead and solve for it. The question did not ask you to solve for it, so just gonna leave it like that. Right. The next one, we asked to solve for that, but we have the function already, so we don't have to set it up. Let me write the timestamp. Right, so we have this function, and x is between 0 and 10, y is between 0 and 5. Interesting. And we have this. And again, we try to find the maximum. Right, so between 0 and 10, now that is a little more interesting. X is between 0 and 10. So this is between 0 and 10. So X is within that band. Y is between 0 and 5. So that will be between 0 and 5. And then we have the 3x plus 2y greater than or equal to 6. When x equal to 0, y equal to 3, because 6 divided by 2. When y equal to 0, x equal to 2. So 0 and it had the equal sign. 0 and 3, 2 and 0. And this have to be, I say, test point. If you put 0 and 0 in it, that is false. So the point 0, 0 does not belong to the solution. So we're going to set opposite to the line. So that's enough to determine that this is the solution. The solution region, overlap of everything. So let's write out the point. There are 5 points. So x equal to 0, y equal to 3, x equal to 5, x equal to 0, y equal to 5. This point is x is 10, y is 5. This point is x equal to 10, y equal to 0, and now x equal to 2, y equal to 0. Of course, we test for this function, try to find the maximum. Z equal to 15x plus 14y. 42. $70. What is 70 and 150? 70 and 150, that's 220. That's more likely the maximum right there. At 150. And now this is not going to be the maximum. So yeah, the maximum is right here. When x equal to 10 and y equal to 5. pause this video and continue the remaining on the next video. Thank you for watching.